Hello guys, David Osinski here, and I will show you a Tesla coil that I have built. It took me about 3 weeks. The main problem I had was obtaining certain components because they are somewhat rare. So let's go over this. Alright, here's a power strip. I turn on the Tesla coil by turning on this little button, and the electricity flows through this wire all the way to this, and basically this filters the electricity because when running a Tesla coil, there's stress put on the neon sign transformer, and this relieves the stress. Now from this we have 3 wires running, both ground and electricity. Alright, here's the neon sign transformer. It takes 120 volts from the wall socket or power strip, and it steps it up to 9,000 volts with a peak at 12,000 with 30 milliamps. And electricity, let's follow the red wire first. Okay, it first stops at the spark gap, and what happens is when enough charge builds up, a spark will cross this gap, and basically it's 2 large bolts. What happens is when the spark crosses the gap, all that energy can transfer to the other side. Problem is, when a spark jumps the gap, it also ionizes the air, and this is bad because the spark gap is a timing device, and when the air is ionized, it allows electricity to flow through easily, and we want a consistent timing. So to help out, here's a compressed air hose. Air compressor is all the way over there, and that quenches the spark gap, which basically eliminates the ionized air. Now the electricity from the neon sign transformer stops here, but also flows towards the capacitor bank, which is located under there. It's basically 2 Chinese capacitors, 10,000 volts. They're rated for 10,000 volts, meaning they can withstand a 10,000 volts. Each are 40 nanofarads, and I have them wired in series, so in total they can withstand 20,000 volts, and their capacitance is 20 nanofarads. Now the energy builds up on one side of the capacitor bank, and also builds up on this side. By the way, that's a radio frequency filter that I'm going to test out later. Anyway, so electricity is building up on this side and on this side from the neon sign transformer, and when it reaches a certain threshold, a spark jumps the gap. This completes a circuit, and it allows electricity to flow from this end through the primary coil, which consists of copper piping, and it flows from one end of the copper piping, which is also held together with duct tape, all the way to the capacitor bank again. So it goes from one side through the spark gap, through all the copper piping, and back to the other side of the capacitor bank. Now, when the electricity flows through this copper piping, it induces current and electricity into the secondary coil, which is right over there. This may seem like a solid color, but it is magnet wire, 24 gauge, wrapped around 1,000 times on a 2-foot long PVC pipe. Now the pipe itself is grounded to the physical ground, or actually to a copper pipe over there, which leads into the wall. Anyway, and so the bottom is grounded, and the top has a toroid. This toroid is composed of several things. On the top, you have top and bottom consist of two metal pie dishes. They're glued together, and around it is aluminum ducting, but this gave me a very rough surface, so to increase the capacitance of the toroid, I taped the entire thing in aluminum duct tape. Solves everyone's problem. Anyway, so basically there's an energy transfer between the primary coil and the secondary coil, and once the two coils are in resonance, electricity will build up and discharge in long sparks. Now these sparks are several hundred thousand volts, low current, but still very dangerous because they're high frequency, over 15,000 hertz, and there's a problem with this because if you get shocked with those, if you get shocked with anything above 15,000 kilohertz, you don't feel it. Your nerves can't sense tissue damage at that high frequency. So basically it starts to cook you from the inside. Not fun, but this is not the most dangerous part. Primary coil is. Once this capacitor bank discharges, there are several amps flowing through the wire at 9,000 volts. Plenty enough to kill you. Also, I have a strike rail, which is the very outer edge. This protects from strikes if one so happens to try to strike the primary coil. Instead, it'll strike the strike rail and go to ground. Now, let's turn on the coil.